Imagine your body running like a perfect machine for 50 years. Then physics wins. Richard Feynman understood why. This is the brutal physics of aging. Welcome back to the channel. Today we're diving into something Feynman touched on throughout his lectures, the deep physical reasons our bodies break down. This isn't about diet plans or supplements. This is about the laws of the universe themselves, and why every cell in your body is fighting a battle it will eventually lose. And it's a battle written into the fabric of reality itself. Let's start where Feynman often started, with the second law of thermodynamics. He repeatedly highlighted its profound importance throughout his lectures. The second law says that in any closed system, entropy, the measure of disorder, always increases. Heat flows from hot to cold. Ordered systems become disordered. Sandcastles crumble. The universe has a direction and it points toward chaos. Here's the punchline. Your body is a system desperately trying to maintain order against this cosmic force. When you're young, your cells have an extraordinary ability to fight entropy. They take in energy from food. They use that energy to repair damage and keep things organized at the molecular level. It's an exhausting, constant effort against the universe's tendency toward disorder. Here's where the brutal physics kicks in. Every chemical reaction in your body produces some heat, some waste, some tiny bit of disorder that can't be fully cleaned up. Feynman emphasized this throughout his lectures. Perfection is genuinely impossible at the molecular level. There's always a cost. There's always leftover entropy. The bill always comes due, even if it takes decades. Let's get specific. Inside every cell are mitochondria, the tiny power plants generating your energy. Each second, they pump out adenosine triphosphate, the molecular currency of life. But this process leaks. About 1 to 2% of the oxygen they use becomes reactive oxygen species, molecular bullets that damage proteins, lipids, and the very DNA holding your genetic code together. When you're 20, your repair systems clear this damage almost as fast as it appears. The cellular accountants balance the books every single night. But when you're 50, the damage accumulates faster than repair can keep up. The books no longer balance. The mathematics of this defeat is described beautifully by statistical mechanics, a field Feynman helped popularize to generations of students. Think about it this way. Imagine you have 100 dice and you're trying to keep them all showing 6. With concentration, you can manage that. But every time you blink, a few flip to other numbers. The longer you play, the more dice are wrong. Eventually, the disorder wins. That's the picture of your body after 50. Too many dice, too few hands. Now let's talk about something even more fascinating. Quantum mechanics. Feynman was a master of quantum theory. He showed us that at the smallest scales, particles don't follow simple, predictable rules. They tunnel through barriers. They jump in unexpected ways. They behave probabilistically. And this strange quantum behavior has direct consequences for every cell in your aging body. In your DNA, quantum tunneling causes spontaneous mutations. Protons in the base pairs of your genetic code can tunnel from one position to another, changing the information stored there. This happens billions of times across your body every single day. For 5 decades, your repair enzymes catch most of these errors before they cause real problems. But that's where the story gets harder. The repair enzymes themselves are made of proteins. Those proteins can become damaged over time. Slowly, the error rate climbs. The proofreaders themselves need proofreading, and there's no one left to do it. This is the hidden compounding effect of aging. The systems that fight damage become damaged themselves, leaving fewer defenders standing on the molecular battlefield. It's systems within systems, all wearing down. There's a beautiful, terrifying symmetry here. The same quantum mechanics that allows life to exist, that powers photosynthesis, enzyme function, and possibly even consciousness itself, also guarantees its eventual breakdown. The universe gives with one hand and takes with the other. The very rules that built you also unbuild you slowly, atom by atom, year by year. It's the cost of being made of physics. Let's look at energy budgets. A core principle Feynman taught is that you can't get something for nothing in physics. Every system has an energy budget, and how that budget is spent determines what's possible. In your 20s, roughly 25% of your daily energy goes to maintenance and repair. By the time you're 50, that percentage has dropped significantly. Why does the budget shrink? Because the basal metabolic rate declines about 1 to 2% per decade after 30. Your mitochondria become less efficient. Your cellular machinery requires more energy for the same repairs. The budget shrinks just as the bills grow larger. It's the worst possible accounting situation, and biology has no choice in the matter. The numbers simply don't balance anymore. This is where Feynman's love of clear thinking really helps. His approach was always to look at the numbers. If you need 100 units of repair work daily and your budget gives you only 80, you fall behind by 20 units each day. After a year, that's 7,000 units of unrepaired damage. After a decade, 70,000 units. The brutal arithmetic of accumulation. Now consider proteins. Your body has about 20,000 different proteins, each folded into a precise three-dimensional shape. The shape determines the function. If a protein misfolds, it doesn't work properly. Sometimes it even becomes toxic to the cell. Heat, oxidation, and time all cause proteins to slowly unfold or misfold across your tissues. Imagine origami that slowly unravels itself with each passing year. Young cells have cleanup systems called proteasomes and lysosomes. These recognize broken proteins and break them down for recycling. After 50, these cleanup systems themselves slow down. Misfolded proteins accumulate. This is part of why certain neurodegenerative conditions often emerge in this age range. The physics has finally caught up with the biology and the consequences become visible. There's another layer worth exploring. Your cells have a kind of internal clock called telomeres. These are protective caps on the ends of your chromosomes. Each time a cell divides, the caps get slightly shorter. Eventually, they become too short to protect properly, and the cell either stops dividing entirely, enters senescence, or simply dies. The clock is ticking inside every cell. This isn't a design flaw. It's a fundamental limitation of how the molecular machinery copies itself, built into the physics of DNA replication. Every time the cellular printing press runs, it loses a little bit of the edge of the page. Eventually, there's nothing left to print on. The body has a built-in expiration mechanism encoded at the molecular level. Here's something Feynman would absolutely appreciate. The aging process isn't a mistake. It's not a design failure or some cosmic glitch. It emerges directly from the laws of physics applied to systems that maintain themselves through energy use. Any system that processes energy must eventually accumulate damage. The universe doesn't make exceptions for living things. Stars age, galaxies age. So do we. Let's bring this together. By 50, several physical processes have compounded. Entropy has accumulated in your tissues. Reactive oxygen species have done their slow damage. Quantum tunneling errors have crept into your DNA. Proteins have misfolded. Telomeres have shortened. Energy budgets have tightened. None of these are separate problems. They're all manifestations of the same underlying physics, all operating quietly, simultaneously every second. Feynman often stressed seeing things clearly without illusions. The illusion many people hold about aging is that it's purely a medical problem with a medical solution. Physics says something different. Aging is the universe's signature written on every living thing. It's the slow, inevitable cashing of the bill that life writes against entropy from the day you're born. Understanding this changes everything about how we think. But here's where things become hopeful rather than hopeless. Understanding the physics gives us real leverage. We can slow the rate of accumulation. We can support our repair systems. We can reduce the rate at which damage outpaces maintenance. The principles are surprisingly simple, even if the engineering of human biology is genuinely complex. Knowledge becomes a tool, not just a thought. What does that look like practically? Reduce metabolic stress where you reasonably can. Support your mitochondria with movement. Sleep deeply, because that's when repair happens at peak capacity. Stay curious because mental engagement drives cellular activity in the brain. Move your body daily because motion drives cellular cleanup throughout your tissues. Each habit translates directly into cellular consequences. These are physics-based observations, not prescriptions. These aren't medical recommendations from this channel, just physics-based observations about systems under load. Always speak to qualified professionals about your individual health situation. The point isn't to prescribe a routine. The point is to understand the deep physics underneath your daily life, so you can make informed decisions with clearer eyes. Information should empower, not replace professional guidance. What's truly remarkable is how Feynman's approach changes the conversation. Instead of seeing aging as something happening to you, you start to see it as the universe doing what universes do. There's a strange piece in that perspective. The same laws that built the stars that ignite fusion in the sun also write the slow story of your cells. You're not separate from the cosmos. You're a temporary, beautiful exception to its general direction. A little pocket of order in a sea of disorder, held together by countless quantum events and chemical reactions that, against all odds, conspire to keep you alive and thinking for decades on end. That itself is a kind of miracle physics permits but does not demand. Feynman would probably remind us that the goal isn't to fight physics. You can't win that fight. The goal is to understand it deeply enough to work with it skillfully, to buy time, to extend the period of meaningful order against the rising tide of disorder, to live with the pleasure of finding things out right up until the very end. The physics is brutal, yes, but brutal doesn't mean meaningless. Within the constraints the universe sets, there's enormous room for curiosity, joy, learning, and connection. After 50, the body slows. But the mind, properly cared for, can keep questioning, keep exploring, keep finding things out. That, perhaps, is the deepest answer physics offers to the question of aging. Wonder is the renewable resource we're given. If this deep dive into the physics of everyday life fascinated you, please subscribe, hit the like button, and comment below with what you'd like explored next. Keep questioning everything.